Hello everybody and welcome to How to CMake Good Part 0C. That's right, we're back to 0 because we're talking about something a little different today. So far all of my work has been done on my Linux box, but Windows users are important too. So I'm going to show you how you can use CMake with Visual Studio, and there's actually two different ways of doing that. You can use Visual Studio with a solution file, or you can open the CMake directory directly in Visual Studio. I have a project that's already using CMake right here, and I want to generate a build for it using Visual Studio. So I'm going to open up a command window and change into that directory. Just like on Linux, we're going to make dir build. I'm going to change into build. And I'm going to use the CMake command line to generate a Visual Studio project. Since I already have Visual Studio installed, I can just invoke CMake regularly and it'll know to generate a Visual Studio solution. Now you can see it's generating a solution for Visual Studio 15 2017. 15 is the actual version number of this Visual Studio 2017 release. Here it's using the CL compiler exactly as we expect it to. If I open up my file browser and I go to build, we can see the generated Visual Studio files. The one you'll want to open will be the main .sln. I'll double click on that and it'll launch Visual Studio 2017 Community Edition. CMake generates a Visual Studio solution where each target is a different sub-project. If I expand a target, I can see its header files, source files, and the CMake lists.txt that generated that target. All of the source files associated with the target are in here, but no other source files are. This is why you should list all your header files and source files associated with a target so that IDEs are able to recognize that a source file belongs to a target and it'll be visible in the project's outline view. We can right-click on a project and say build to build the project. This will build the target associated with that project and all targets that it depends on. Here's our build. We can see it compile files and then it succeeds. At the very beginning, it runs a special project called ZeroCheck. This is the project that will check if CMake's configuration data is out of date and it needs to regenerate the Visual Studio project. All projects will depend on this ZeroCheck project. You can also build the ZeroCheck project yourself to manually regenerate the configuration from within Visual Studio without having to build any projects. Now that it's compiled a project, we can now run as an executable by right-clicking on it, clicking Set as Startup Project, and then starting the debugger. It'll ask us to build it. You might want to check the Do Not Show This Dialog Again button so that it will automatically rebuild relevant targets when you need to debug them. I'll say yes for now. It's compiling the executable, it launches it in the debugger, and it's done. That was a pretty simple executable. Let's expand its main file and set a breakpoint. And here we are, in the debugger, debugging our CMake target. You may know that CMake generates a variety of build types. Up here, there's a small drop-down which includes the build types that CMake has generated for us. If I go back to simple.cpp and I make a special block like this, Visual Studio will automatically colorize this block section when it's disabled. If I change the build mode to release, Visual Studio has recolorized this block because it is now disabled by the release mode. Note that I did not have to rerun CMake to change the build type. Visual Studio Solutions already know about all of the build types. CMake was not rerun when I changed the build type. CMake just generated a project which contains all of the information needed to build all of the builds all in a single pass. This is different from Makefiles or Ninja files where you need to rerun CMake to change the type of build. This is called a multi-conf generator and we'll delve into those a little more in a later video. If I go to the File Explorer, we'll see a directory called Examples and a subdirectory called Debug. This is where Visual Studio generated the executable that I just ran. It's generated in a subdirectory called Debug because Visual Studio allows us to build the release mode within the same build tree. I've set the build type to release, and if I run the build, and then I go back to the File Explorer, it's now created a release directory with another simple.exe in it. This way you can have both debug and release executables side by side and switch between them quickly. Now, I'll show you how to build this project from the command line. I'll say clean solution, and it will remove all of the built files. Now I'll close Visual Studio and go back to the command line. Our project is still there, and we can still build it using CMake. CMake -- build dot. And then we say what configuration we want to build. --config debug. CMake will run the underlying MSBuild build tool in order to build this Visual Studio solution. CMake natively understands how to drive MSBuild to build its generated projects. This means you can use Visual Studio solutions without even having an installation of Visual Studio present. The Visual C++ build tools are sufficient to generate and build Visual Studio solutions without having the actual IDE installed. We can also build specific targets by using the -- target flag. I'll build the simple target that we built from Visual Studio. You can see it ran the build for the single target. It was already up to date, so if we change the configuration to release, it'll actually rerun the build. It's only compiling the needed targets that are necessary to produce the target I asked for. And now we'll do something a little bit special. We don't even need to generate a Visual Studio solution to use Visual Studio. In my build directory, I'll clear it all out. I'll go to my source directory, right-click, and say Open in Visual Studio. Visual Studio detects the CMake lists.txt and is able to open it natively without any special commands needing to be run. It shows us the file system structure in the Solution Explorer as if it had generated a real solution. In the CMake output, we can see that it ran CMake for us and generated a new build directory in a temporary path. It also generated for Ninja, which is a very special tool that I'm going to get into in another video. It also used an embedded version of CMake. This contains some special patches from the Visual Studio developers to support Visual Studio in this way. That's all I wanted to show for now. Check the video description for any addenda, errata, important links, or extra information. In the next video, I'll show how you can use Visual C++ without using Visual Studio or MSBuild. Until next time, keep CMaking good.